This is a Squiz podcast. We're your shortcut to being informed.
Squiz Kids!
It's your daily news fix. Fun, free, fresh.
Hello there, and welcome to a very special Squiz Kids Q+A, part of our ongoing series of interviews with people in the news, where you, the kids of Australia, get to ask the questions. I'm Bryce Corbett. Today, we're delighted to welcome to the Squiz Kids hot seat a man who has been in the news a lot in the past month. His name is Dr. David Flannery. He lives in Brisbane, and he was part of the team of clever scientists who put the rover Perseverance on Mars. Perseverance took 7 months to travel 470 million kilometres to touch down on the surface of Mars, where it will now spend anywhere up to 10 years searching the Jezero crater for signs of life. It's mind-boggling stuff. It's stare up into the night sky and marvel at how vast it all is material. And from his office at the Queensland University of Technology, Professor Flannery has the responsibility of programming the Perseverance as it trundles about on a planet that is so far away it appears as the tiniest speck in the sky. Mind blown. We couldn't be more excited to have him take part in a Squiz Kids Q&A, and nor could you, judging by the huge number of questions we received. Professor Flannery, welcome to Squiz Kids.
Thanks very much for having me.
You're very welcome. Now, can I just say before we begin that we've done Q&As like this before, but never have we had so many kids write to us wanting to ask a question, and they are excellent questions too. Now, I know you're a scientist used to being under pressure, but are you ready to be grilled by the kids of Australia?
I am totally ready. Let's do it.
All right, let's jump straight in. The first question comes from Annabelle and William in Kingaroy in Queensland.
Hi, Professor Flannery. My name is Annabelle. I am 8 years old and I'm from Kingaroy in Queensland. My question is, what life forms are you expecting to find on Mars? What will you do with them if you find them?
Thanks, Annabelle and William from Kingaroy. We're looking for everything. We've really got our eyes and minds open. But if the record of life on Earth is any guide to go by, we're probably going to find really small evidence for life, really small organisms, microbes. So before animals and plants evolved on Earth, all we had on the planet were tiny little microorganisms, and so they're the sorts of life we're looking for in these really, really old rocks on Mars. And so if we find a fossilized microbe on Mars, what we'll do is try to drill it out of the rock and bring it back to Earth so we can study it in our labs back home.
How cool is that? And now to a question from 7-year-old William from Kingaroy.
My question is, how does the rover pick up tiny particles? Is it like a vacuum cleaner?
I really like the vacuum cleaner idea. In fact, we have almost a reverse vacuum cleaner on the Perseverance rover. We have a tank of helium gas and we blow puffs of the helium on the rock. Like, we sort of breathe on the rock and that clears the dust away from the rock and gives us a much better view. So almost like a vacuum cleaner running in reverse. We can't pick up particles of dust and sand with that. But what we can do with the drill rig we have on the rover is to take little core samples. They're about the size of a pencil, these samples, and we drill them out of the rock and stick them in a tube. They get broken up in the tube. They sort of look like a stack of M&Ms. And we'll bring those back to Earth with a series of follow-on missions. Maybe 20 years from now, we'll be looking at those particles that we pick up on Mars.
Amazing. Now we have a question from Alicia from Queensland with what I think is an excellent question.
Hi, Professor Flannery. My name is Alicia. I'm 9 years old from Rochdale. And my question is, how many times did you fail and what did you learn from those failures?
Well, I think it's okay to fail. In fact, it's really essential to fail in science. You set yourself up to fail and you learn from your failures and get better at what you do. And when we were developing this mission, we tested every component we had. We tested all of our instruments on the rover and all the materials we used and the rover itself to make sure that we knew exactly how things were going to fail so that we could build something that we hope won't fail. Now, obviously, there's some things you can only do once, like arriving at Mars and landing on the surface without crashing. You don't want to fail there, but actually that's really common as well. Most missions to Mars have failed, and so, look, failure is totally okay.
Well, that's going to become my new mantra for life, frankly. Question now for Riley and Lily from Year 5-6 at Hopeton Primary School in Western Australia.
Hi, Professor Flannery. My name is Riley and I'm 11 years old and I'm from Hopetown, Western Australia.
My name is Lily and I'm 10 years old.
My question is, when is a rover coming back if it comes back?
And my question is, will we be able to eventually live on Mars?
Wow. Well, they're two related questions, because it's not easy to get to Mars, but we can do it. But we've never brought anything back from Mars. And so this rover is not going to come back, unfortunately. Perseverance, or Percy, will spend maybe up to 10 years exploring the surface of Mars, but the rover weighs nearly 1,000 kilograms. It's about the size of a big car, and it weighs about as much. And it's really difficult to get all of that mass, all of that weight off the surface of Mars and bring it back to Earth. But what we will try and do is bring back a few rocks, maybe only a few 100 grams of rocks, and so that'll be a really big challenge to get those back. And that brings us to the next question from Lily, which is, will we be able to eventually live on Mars? And I think eventually, sure, we'll be able to live on Mars. In hundreds of years, I'm sure we'll be living on the Moon and on Mars, and we'll have the capability to live in space stations, and under the sea and under the ground on Earth. But my question is, will we want to live on Mars? Because Mars is actually a pretty difficult place to live. And it'd be much easier to get there than to come back, not just for robots, but also for humans. So my first question would be, can you get me back? And how are you going to keep me alive there? And it turns out that the environment on the surface of Mars isn't all that pleasant.
All right, good to know. Then maybe I won't be putting it on my holiday list anytime in the immediate future. Let's go to Porapunka now, at the foot of Mount Buffalo in Victoria, where Oscar and Millie have a question for you.
Hi, Professor Flannery. My name is Oscar, and I am 10 years old. I'm from Porapunka.
My name's Millie. I'm 9 years old.
And my question is, what do the skies on Mars look like?
And my question is, how hot is Mars?
Well, I've never seen the sky on Mars, but some of the robots that we build see the sky on Mars through their robot eyes, and they send us back those pictures we can look at. And when I look at those pictures, the sky on Mars looks pretty much like the sky on Earth. The sun is smaller because we're a lot further away from the sun. But when you look at the sun coming up every morning, the sky around the sun is blue, just like on Earth. But because there's a lot of dust in the atmosphere, sometimes when we look elsewhere in the sky, it's much redder than we would expect the sky to look on Earth. And the next question from Millie, I think, is, how hot is Mars? And really the question is, how cold is Mars? Because on average, Mars is much colder than Earth. The landing site for the Perseverance rover, the temperature varies from about 0 degrees Celsius, so like a really cold day in the snowy mountains, to minus 100 degrees Celsius. So
wow.
Colder than the coldest day ever recorded on Earth in Antarctica. And what's even more of a problem is that 100-degree difference, it can happen in a single day.
Wow.
So in the midday it can be 0 degrees Celsius, but then it gets colder in the afternoon, and at night time it can be minus 100. And so all of the bits of that rover, they have to deal with those temperature changes every single day. And so would humans if they wanted to live on Mars.
So you'd need to pack your winter woolies then if you're going to Mars.
I think you definitely want a really good coat.
Jumping back up to Sydney now, where Fadi from Fairfield Public School has an excellent question.
Hi, Professor Flannery. My name is Fadi. I am 8 years old and I'm from Fairfield Heights Public School. My question is, if there is water on Mars, does that prove there is some kind of life on Mars?
Well, Fadi, there is water on Mars. We've discovered water on Mars in many different areas. Most commonly, water is present in ice. Mars has ice caps, sort of like the Earth has a lot of ice at the poles in Antarctica and in the Arctic. So does Mars. It has kilometers thick layers of ice, of water, and also carbon dioxide. And we can see by looking at the surface of the planet, we can see areas where water has flowed across the surface and changed the landscape. At some point in the past, there must have been a lot of water moving around on the surface. So we don't know exactly when that water was there, but we know that Mars had a lot of water. And so it stands to reason. Some of us think that maybe things could have survived on the surface because we had water and we had a nicer place to live. But now the planet dried up and it's really cold and dry and not the sort of place that life as we know it on our planet could survive.
Amazing. Moving on to the next question, which comes from Jessie in New South Wales, and it strikes me as an excellent technical question.
Hi, Professor David Flannery. My name is Jessie. I'm 10 years old and I'm from New South Wales. My question is, how do you control the Mars rover from Earth with the time delay between Earth and Mars?
We can't drive the rover directly. We just tell the rover what we'd like it to do. For example, go over there and have a look at that rock. And the rover has a brain of its own. It's got a computer and it knows how to drive itself over there without getting hurt and take a look at that rock.
Amazing. Another budding scientist here, Will, from Romsey in Victoria, has a question for you.
Hi, Professor Flannery. My name is Will Sargent and I'm from Romsey. I'm 9 years old. My question is, how are we going to get all the rocks collected by Perseverance back to Earth?
Well, getting rocks back from Mars to Earth is the next really big challenge in space for all humans. And that's what NASA's trying to do. It's what the European Space Agency is trying to do, and the Chinese Space Agency. They're all trying to get some rocks back from Mars to Earth. It's actually a really tricky problem because we have to go and collect the rocks, and that's what the Perseverance rover is doing. We're collecting all these rocks, but then we have to get them back. And the first step there is to take them off the surface of Mars and put them into orbit around Mars. So we need to send a rocket to Mars and blast off from the surface with our rocks and put them into orbit. And then we need another mission, and maybe we could send humans on this mission to go and grab those rocks in Mars orbit and bring them back to Earth.
Unbelievable. And how many years in the planning is that mission?
It's being planned now, and the Perseverance rover mission is the first mission in a series of 3 missions that we'll need to eventually get those rocks back. So the next mission will send a rocket and a rover to collect those rocks, and the rocks will be put in that rocket and they'll be blasted off into orbit. And then that third mission, well, that might be at least 10 years away.
Jumping now to another excellent technical question from 7-year-old Marco in Melbourne.
Hi, Professor Flannery. My name is Marco. I am 7 years old and I'm from Melbourne. My question is, where does Perseverance get its power from?
So most rovers that have gone to Mars are powered by the sun. Mars is further away from the sun, so we can't get as much energy from solar power as we can on Earth. And so if you've got a really big rover, like Perseverance, as big as a 4-wheel drive, you need a different power source. And what NASA has used is a chunk of plutonium. Plutonium's radioactive. This chunk's about the size of a tennis ball, and it generates a lot of heat. And on the rover, we can convert that heat into electrical energy. And so we also use that heat to keep the rover warm because, as we just heard, Mars is really cold. And that means we can operate the rover for probably 10 years or more. So when you're in university, maybe this rover will still be moving around on the surface.
And all thanks to a tennis ball-sized chunk of plutonium. Unbelievable. The last question goes to Luca in Sydney, who has a question which I have to admit I wasn't quite sure how to take.
Hi, Professor Flannery. My name is Luca. I am 9 years old and from Sydney. My question is, when will Bryce, the host of Squiz Kids, be able to go to Mars? P.S. I'm not trying to get rid of him.
I feel like he's trying to get rid of me.
Sounds like he's trying to get rid of you for sure. Yeah. Well, if you really want to go to Mars, you'll probably have to wait at least 20 years. And so I'd encourage you now to start applying to NASA's astronaut program. Or maybe by that time, Australia will have some astronauts of our own. And it takes a long time to get qualified, so you better start now.
Well, there's a challenge for all of you to become the astronauts of tomorrow. What an excellent idea. Well, sadly, that's all we have time for today. Professor Flannery, thanks so much for taking the time to chat to us and taking us on this fascinating foray into space. It's been out of this world.
Anytime. Thanks for having me.
Now, before you go, as promised, we have a prize for the best question asked of Professor Flannery today. The prize is a space atlas.
So my favourite question today was from Alicia in Queensland, who asks, how many times do you fail when you're trying to build a robot that goes to Mars? And what do you learn from your failures?
Congratulations, Alicia. It was an excellent question indeed. And can I just say the competition was really tough. A huge thank you to all of you Squiz Kids who sent in questions. We had so many questions from all corners of the country, and every single one of them was excellent. Hugely appreciated. Unfortunately, we ran out of time to use them all. Thank you again, Professor Flannery, for taking the time to chat to us today.
Thank you.
And remember, folks, the Squiz Kids podcast, a daily fix of kid-appropriate news, is out at 7 a.m. every morning via the Squiz Kids website, squizkids.com.au, or wherever you find your podcasts. This is Bryce Corbett signing off, and Professor Flannery, would you please do the honours?
Now get out there and have a most excellent day.
Over and out. Squiz Kids is proudly supported by the Judith Neilson Institute for Journalism and Ideas.
Squiz Kids! It's your daily news fix. Fun, free, fresh.